So we talked about what happens when you drink a glass of water, and so it's only fair that now we talk about what happens when you eat a bunch of salt. So we'll start with our same toy model, and we'll draw our little solutes in. And now let's eat a big salt meal. So the first question again is, where does that salt go? And it turns out that just like drinking a glass of water, the salt is going to go straight into the extracellular space. So initially we still have our cell here at the same size and the same number of solutes inside the cell, but now we've added a whole bunch of solutes outside the cell. And so now the concentration of solutes outside the cell is higher than inside, and so we're going to have an opposite fluid shift compared to the one we had last time. Now fluid is going to flow out because of the osmotic pressure. And so now the cell is actually going to lose some volume. It's actually going to shrink down and shrivel up a little bit. And it'll reach equilibrium when the concentration of solutes outside and inside is once again equal. And so what was the result of this? Well, we didn't add any fluid, we only added salt, and then fluid moved from inside cells to outside. So therefore, we're going to have an increase in extracellular volume and a decrease in intracellular volume. And the concentration in both of these areas is going to have gone up because we just added solutes. So an increase in extracellular concentration and an increase in intracellular concentration. And there's actually another situation that's kind of similar in terms of what happens. And that is that instead of adding salt, you can take away water. So one way you might imagine that could happen is maybe if you go to the desert where there's a lot of cacti and you're sweating a lot, you're breathing out a lot of your moisture, the dry air is just sucking a lot of the water out of your body. And it originally comes out of this extracellular part here, so that we go to a situation where we have less water. And let's say initially, the cell is the same size as before. And so as a result, we see that the concentration of solutes outside the cell has gone up quite a bit. So because of that, osmotic pressure is going to pull water out of the cell, and we will go to an equilibrium that looks more like this. Now our cell is more shriveled up, and we've got our solutes floating around such that the concentration inside and outside is the same. So if we compare this situation to this one, we see that we have actually lost extracellular volume, lost intracellular volume, but we've gained extracellular concentration and gained intracellular concentration. So I'm saying these are similar because in both cases you have a shift of water out of the cells, but the difference is that here initially you lost a bunch of volume through water, which is why the volume of both went down. Okay, so let's go back to that initial situation where we have our extracellular fluid and we have a cell inside, and the concentration of solutes is the same inside and outside. So now let's ask what happens when we drink a bottle of water. So we're going to drink a whole bottle of water. And the first question is, what does that go into initially when you drink a bottle of water? Does it go into the extracellular compartment or the intracellular compartment? So it turns out that actually the fluid goes into your intestine, and your intestine is lined by cells like this. These are epithelial cells. And the fluid goes into here, and then when it's absorbed, it actually gets absorbed across the cells. So it goes into this space here, which is extracellular. So that means we should add this water to the extracellular part. So let's do that. So now the water level has risen from here all the way up to here, and we still have our cell floating around in there. And we still have our solutes, which have not gone from one compartment to the other because they can't go through the membrane. And so now what you'll notice is we added water to the extracellular part here, and there's still the same number of solutes, so the concentration of solutes in the extracellular part went down. And so now suddenly the inside of the cell has a higher concentration, and therefore it's going to drag in some fluid by osmosis and increase in size. And so what's this picture going to look like? Let's move this intestine out of the way so we can see. So now fluid is going to shift from the outside of the cell to the inside of the cell, and so the cell is going to get bigger until the concentration of solutes inside the cell is equal to the concentration of solutes outside the cell. So this here is the equilibrium state that's been achieved after we added some water to this situation. And the net result is that both the extracellular and the intracellular compartments gained volume. They both got some of this water. So if you add pure water, the result is an increase in the extracellular volume and an increase in the intracellular volume. And this is just a toy example, so if you're wondering how this works in a real human, well, actually fluid will shift into every cell in the body. A little bit of fluid into each and every single cell. And it'll shift around like that until the concentration of solutes has equalized between all the cells and all the extracellular fluid. And so the other thing you'll notice that's different about here and here is that here we have now a lower concentration of the solutes inside and outside. So we can say decreased extracellular concentration and decreased intracellular concentration. So we've talked about what happens if you add water and what happens if you add salt. And now finally let's talk about what happens if you do both. So here's our starting point, and then we're going to add fluid and salt. And we're actually going to add fluid that has the same concentration of salt as the extracellular fluid. So we're going to bring the fluid up to this level, and we're adding enough solutes so that it has the same concentration as the extracellular fluid. And what happens when you mix two solutions together with equal concentrations is you get another solution with the same concentration. So when we've added this fluid, the concentration of the extracellular fluid does not change, and so you're going to have no shift of water because the concentration inside and outside is still the same. And this kind of fluid that has the same concentration as the extracellular fluid is what we call isotonic. Tonicity, which is where that part comes from, tonicity refers to the concentration of solutes, but specifically the solutes that can't cross this membrane. And iso means same. So isotonic fluid is fluid that has the same concentration of solutes that can't cross this membrane. And so what we've learned here is that if you add isotonic fluid, you get an increase in extracellular volume, and your intracellular volume does not change. And similarly, the concentration of both compartments does not change. So isotonic fluid has the same concentration of salt, but what happens if we add fluid that has a lower concentration? And that is what we would call hypotonic. Hypo means less. And it turns out that this is exactly what we did when we added pure water. Pure water is hypotonic. It's extremely hypotonic. It has no solutes in it. And what happened when we added pure water is we had an increase in the extracellular volume, we had an increase in the intracellular volume, and we had a decrease in the concentration of both compartments. And then what's the third example? The third example is adding hypertonic fluid. So hypertonic fluid has a higher concentration of salt than your extracellular fluid. And this is pretty much the same as just adding salt. Adding salt is like the most extreme example of this. So when you add hypertonic fluid, what you get is an increase in the extracellular volume, a decrease in intracellular volume, and an increase in the concentration of both compartments. So you'll notice that every single one of these is going to increase your extracellular volume. And that's because when you add that fluid, it goes straight into the extracellular volume. But let's say you add 1 liter of this one, 1 liter of this one, and 1 liter of this one. Which one is going to increase your extracellular volume most? The answer is the hypertonic fluid. And that's because you're adding a liter of fluid, but you're also adding a bunch of salt. And that salt is going to drag more fluid out of the cells. So basically you're giving not just the liter, but the liter plus whatever it's going to steal from the cells. And hypotonic is going to give you the least volume, because you're going to put in a liter, but then some of that water is going to go into the cells, so you're really giving a little less than a liter. So now that we know how fluid and electrolytes are distributed in the body, we can finally talk about what happens when we add fluid or electrolytes to the body. And the easiest way to think about this is going to be to use a bit of a toy model, and to imagine that instead of talking about intracellular and extracellular components, we're just going to imagine a cell that's floating in a cup of water. And so the inside of the cell is going to represent the intracellular compartment, and the outside is going to represent the extracellular compartment. So as we talked about, these things have different solutes dissolved in them, but they have the same amount of solutes dissolved in them. Because if they had different amounts of solutes dissolved in them, then water would move so that the concentrations of solute became the same. So for example, if we had a really high concentration of solutes here inside the cell, and it doesn't matter which ones, it just matters that they can't get through the cell membrane. We have a high concentration here and a low concentration out here. Then this high concentration is going to drag water in by osmosis. So if we wait just a short amount of time, the water is going to shift, and we're going to get a new picture that looks a little different, where there's still the same total amount of fluid in both the intracellular and extracellular parts. But a lot of fluid has moved into the cell, and so the cell has now gained volume. So that now the concentration of solutes inside and outside the cell is going to be the same.